reaction at all to that pun?
I didn't even know.
Ouch. Ouch. It's okay. Yeah, I made a pun about it being warm in here.
Oh, okay.
Yeah. Obviously a complete flop if I had to explain it. Like, horrifically went wrong. Okay. All right, folks. So we left off last time on naming the aldehydes. So for naming the cyclic aldehydes, we're going to have to establish the root as a cycloalkane carbaldehyde. And that's because you're going to have an additional carbon here if you have an aldehyde. Because what's true about an aldehyde? It has a hydrogen, right? If you're in a ring and you have two bonds to a carbon, carbonyl, carbon-oxygen, you can't have a hydrogen in the ring, can you? Yeah. And so this is always how you end up having to do the aldehydes in rings. So the number of the carbons in the ring, the C1, is going to be right there, which is going to be attached to that carbon. That will be the aldehyde carbonyl. Okay. Another way of calling that is that as the alpha carbon. Everybody okay with that one so far? Right. Fantastic. Anybody have any questions about naming aldehydes in rings? Okay. Yeah, and if this is the suffix, what's the numbering way start with on the aldehydes? Yeah. If an aldehyde is the suffix, what's the numbering ways have to start with for that first aldehyde carbon? 1, yeah, because it always ends up having to be at the end of something, doesn't it? Yeah. And if you have a second aldehyde, what is that one? That one's always the last carbon, right? Yeah, because it always has to be at the beginning and ends of chains, don't they? Okay, except for the cyclic, then the ring's the 1, 2, 3. All right, so let's talk about naming carboxylic acids. Now, carboxylic acids are actually easier thought of as the carboxylic acids and their derivatives. Okay? So the carboxylic acids, and then you have the acid chlorides, the amides, and the nitriles. These different functional groups are all carboxylic acid derivatives. Are you okay? Okay. 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 And so in all of these different derivatives, you're going to be replacing these groups, okay? They're very similar. They have reactions that will interrelate all of them, okay? And you can go from one to the other repeatedly. So determining the highest priority functional group, this gets the suffix in the name, of course. So in this case right here, our suffix is going to be that carboxylic acid. And so we're going to put that as oic acid at the end. We'll replace the E from the end of that alkene, right? Everybody good with that so far? Fantastic. The 1 carbon will be that one that's in the carbonyl, the carboxylic acid carbon. That's the one you normally would have written as COOH. Everybody remembers writing that on some of these things? Yeah. Yeah. If you ever written out any of the amino acids, that's that group right there. You're going to determine your longest chain containing that group, of course. You're going to number accordingly, lowest possible number to the carboxylic acid. Notice that the carboxylic acid is essentially almost always, basically always going to end up being a 1 or the last carbon. Because again, we're taking up 3 of the bonds on that carbon, aren't we? Okay? All right, so identify and number the remaining functional groups. In this case, we have the double bond here, and we have that carbonyl, which is going to end up being an oxo group, right? Because that one is the prefix for that carbonyl. Okay. This one right here, we actually have 2 carboxylic acids, and so we're going to number it in such a way that our lowest numbering ends up being for this carbon chain off of here, right? Because either way we start numbering, it ends up being 1 for a carboxylic acid. And we can't minimize the number of this other one because it has to be at the end of the chain. Okay? All right, so Nitrile functional group is always going to be part of the functional group. So right here we have the nitrile. Notice the carbon is always part of that functional group because a nitrile is a nitrogen triple bonded to a carbon. Can everybody see it okay? Okay, fantastic. When the nitrile is the highest priority functional group, that carbon is going to be counted as part of the chain. And so you'll lump that in as your first carbon, okay? And we start with that as 1. When the nitrile is not the highest priority group, this carbon's not counted as part of the chain. The cyano prefix is actually going to include that carbon. This is probably the weirdest one. It's the one where a lot of the patterns kind of break, okay? And so it's funny that people actually have a tendency to remember this because it's the unusual one. But yes, it is where things get a little weird. Okay? So did everybody catch how this is different and how this is weird? Okay, so if it's the suffix and we start the numbering from it, what do we include? We include the carbon in this nitrile group, right? And so number 1 is right there. Everybody see that okay? Okay. If it's not the highest priority and we're not going to put it as the suffix, if we're going to end up putting the prefix version of it, which is cyano. Cyano actually includes the carbon in the prefix. And so we can't actually use that carbon as part of our chain. Because then we would have an extra carbon in that name. Okay? And so what ends up happening is we number it. This one's the suffix right here. Okay? And that's the higher priority one. So that one gets 1, 2, 3. That one doesn't get numbered. Because now that's a substituent. I know. I didn't make the decision. I'm going to step back from this decision because it's kind of stupid. But it is the decision that was made by IUPAC. Now you know what my advisor was like. Fuck those people. Can you blame him? I mean, some of these decisions really weird, right? The reason they wanted this, by the way, there is a reason for this. This carbon right here, because it's in that triple bond with an electronegative atom like that, it has some interesting chemistry that happens there. Okay? So treating it as its own group actually makes some sense. But they did a weird thing in that they did it one way when you start with it, and one way when you finish with it. And it makes it just bizarre, right? But hopefully it kind of sticks out in your memory because it's the only time we have something weird like this. Okay? Okay. Was that clear? It is an additional thing you're going to have to try to remember, but yeah. Okay. Yeah, I wouldn't have probably done that way either. All right, so let's go ahead and talk about the amides. Has anybody ever heard of an amide before? Yeah, no? Okay. If you go into biochemistry, you're going to hear about them a lot. Okay? So has anybody ever heard of a polypeptide or a peptide linkage? Okay. A peptide linkage, they came up with their own name because they had to be special. And a peptide linkage is an amide linkage. That's what it is. It's an amide. That's the functional group. It had been identified and used for almost 60 years before they ever named it. And for whatever reason, they decided to give it a new name. Kind of like a physicist did with far infrared spectroscopy. They renamed it terahertz spectroscopy. And then wrote a bunch of grants saying we're doing new work that's never been done before, taking spectra in this region. It had been in use for 120 years in chemistry. New. All right. Okay, so here we have the amides. Again, it's going to follow that same classification trend as the amines, and that's because they are amines. They just happen to be bonded next to a carbonyl. Can everybody say that okay? They are one of the carboxylic acid derivatives. See how it looks a bit like a carboxylic acid? Yeah. Okay, so if we have the amide with no other carbons on that nitrogen, that's a primary amide. If we have it with one other carbon group, one other chain, then it's a secondary amide, right? If we have it with two other ones, then that's going to be a tertiary amide. So 3 carbon chains attached to it. Everybody okay with that? Note that you can actually have 4 attached to it, and that's going to be a salt. Okay? They'll have that positive charge like the amines did. So, again, we're going to have to use those N locators to identify the locations of those groups that are attached to these nitrogens in the amide. The carbamyl, is the prefix used for the amides that are not the highest priority functional group. Those are the ones like this right here. So that's a carbamyl. Okay? Everybody want to try to say that with me? Carbamyl. Yeah, it's a little bit awkward, okay? Make sure that if you're trying to interview and you're going to have to say that or you're doing a presentation, you actually practice a little, okay? It is something that's very easy when you're presenting to get messed up. Yeah. Okay, so the amide carbon, this is not numbered when the amide is a substituent. So when we have the amide as a substituent here, this is not going to be numbered. Can everybody see it okay? Fantastic. All right, anybody have any questions about that? Okay. All right, we're going to do a quiz. Okay, I'm going to go ahead and move on to the quiz because you can also join from that slide as well. Ooh, that $7 at work. Okay. So, what's the IUPAC name for L-asparagine, shown in its unionized form? In physiological conditions, it would normally be ionized, by the way. Don't worry about the stereochemical designations. Just leave those apart. Please make sure that you register for these quizzes and do them. They're also my attendance, right? So even if you are having trouble with the problem or don't understand it, still register and do it, okay? Also, that helps me know, hey, I need more examples for this, Dr. Clausen, this isn't making sense to me. Usually my cutoff on these things is somewhere in like the 75% if it's a brand new topic. If it's something a bit more, then it would be like in the high 80s, 90s. And we've been hitting those pretty regularly, so. Okay. Okay, folks, I'm going to start going on. Please go ahead and put in an answer if you haven't already. Make your best guess. I'm going to point out a little something before we actually solve this. In a multiple choice question, I have to give you a certain amount of information, don't I? And those are the answers. So if you look at the answers in a multiple choice question, in this case especially, where I wasn't super careful, I've given away a lot of information about this, haven't I? Okay? For example, there's carbamyl in a bunch of these, right? So what's the carbamyl? Substituent form of that amide, right? Yeah. So that's going to end up being a substituent form, isn't it? Yeah. And the other ones, I have O8, oic acid, oic acid, oic acid. So guess where my numbering starts? The carboxylic acid, right? I have to start with that as my numbering. Okay. Okay, folks, so the majority was 2-amino 3-carbamyl propanoic acid, and that is correct. Perfect. Okay, let's go ahead and go on to the numbering and why. So the first thing I would always do for these problems is I need to figure out what my highest priority functional group is, right? So what's my highest priority functional group? Carboxylic acid. You got it. Okay, and if I don't remember or don't have the table available to me, one of the easier things to do is kind of go, hey, what would be the more oxidized form, okay? The oxygen typically is more oxidized, right? Okay. And that will get me correct 90% of the time, okay? So if I don't remember for whatever reason or I get confused, look for more oxygen, more oxidized. Okay. And so again, this is going to end up replacing the E with oic acid. This one right here is carbamyl. Now, when carbamyl is a substituent, what happens to the numbering? Ooh, it does that weird stuff with the numbering again, doesn't it? Yeah. So in this case, we'll start off with 1 being right there, right? Then this is 2, 3. We get to the carbamyl, and we don't number it. Okay? So, what are the other functional groups for this, by the way? So we have this one, carboxylic acid, right? Okay. What's that one? Okay, it's an amine normally, right? And when we have it as a substituent, that would be amino. Okay? Easy way to remember that if you ever forget is amino acid. Literally, the name is the IUPAC name for the overall class of compounds, right? Okay. And so now I just need to assemble these things. Okay? So number 1 is going to be the carboxylic acid, right? And that's the suffix. I don't really have to number that. That one's fine on its own. The next part is going to be the prefix is 2-amino because it's on the second one there, and that's amino. The next part is going to be the prefix, which is carbamyl, again because that's A versus C, right? And that numbering is going to be attached to the third one right there. And so that is 3-carbamyl. This is probably the part that's going to trip the most of you up when you actually do these without kind of sloppily done options, if I give you more different options. And that's the number of carbons that's going to be in this parent, okay, the root. So in this case, the number of carbons in the root is going to be 3, yeah. And that's propane, right? That goes to propanoic acid, okay? And this only happens on 2 cases, that is the carbamyl and the nitrile, right, or the cyano, when we have those 2 substituents, okay? Every other case, the substituent doesn't include the carbon, all right? And you can kind of think of it as, in these carboxylic acid derivatives, the functional group, the carbon's included, okay? And so if you have 2 different functional groups, what always ends up happening is one of them will include the carbon. That's the suffix, right? And that allows us to count those off. The other one ends up being a prefix, and so the carbon doesn't end up being in the root. Is that making a bit more sense? Okay. That's the pattern you can help yourself with. Okay. Okay, so let's go ahead and talk about these carboxylic acid derivatives on a ring structure. Here we have our rings, and then we have the carboxylic acid that's coming off the ring. Everybody see that okay? In each of these cases. All right. So you're going to include both the ring and the functional group in the root name. So your cyclic carboxylic acid is going to be a cycloalkane carboxylic acid. The cycloalkane carboxyl amide is this amide right here. And then cycloalkyl carbonitrile is this one right here with the nitrile group off that ring. Okay. Is that making sense so far? So you always take the ring, and you're going to include the ring as part of that root name. This will then end up being the suffix right there. In these cases, though, because you can't actually include that group into the ring, because it takes too many bonds, it's going to be one carbon off the ring. Okay? You can think of it a very, very similar to the naming when it's the prefixes as well. Okay? Okay, so we're going to go ahead and then number the carbons on the ring. The numbering will start where this group attaches to the ring as 1. We'll then minimize any other functional groups as part of that name. Okay, so let's go ahead and look at the exact examples here. This is a ketone, right? And so that is 3-oxo, cyclohexane, because it's 6 members in the ring, right? And then it's going to be carboxylic acid, because there's a carboxylic acid attached to that ring. And that would take priority. That would end up being the suffix. Okay. Again, the carboxylic acid part doesn't need a numbering. Mm-hmm.
So that's instead of the normal carboxylic acid suffix, when
Yeah.
you say like oic acid,
Exactly.
you have to put carboxylic acid.
Exactly. Yeah. Because we have to recognize that there is a carbon there. Yeah. That this really is more like the prefix naming than it is the normal suffix.
Because normally you would include the carbon if it was like a chain, but since you're
Got
not
it.
including the carbon,
Yeah.
you recognize.
Yeah, we can't include the carbon, so we have to recognize the carbon as part of the suffix coming out of the normal numbering.
That-
Yeah. Otherwise, people might try to draw this as some sort of ring coming off here, right? Yeah. And then you'd be, what in the world? Yeah. Okay. And so the next one's going to be cyclopent 5, right? Now this one has a double bond, so we have to number that double bond. And so that's going to be 2-ene, and then carboxylamide. Everybody okay with that so far? Okay. Everybody want to try to say that with me? Carboxamide. Okay, fantastic. This next one, cyclobutane, form a ring. Pretty straightforward there. The next part is going to be carbonitrile. And again, that's the extra carbon is being recognized. Yeah. Because if we had just had a nitrile at the end, that should have been in the ring somehow. Yeah. But we couldn't fit it. All right. So let's talk about naming esters and acid anhydrides. So the rules for naming the esters and acid anhydrides is again differ from those for the other carboxylic acid derivatives. They're both made up of 2 parts that have to be named. It's common for these parts to be different from each other, so you very often end up with 2 different parts to that and not a di something. The same thing on both sides. So this right here, we have the alkyl groups. These could be any number of carbons. It doesn't really matter. That's our ester right there. Is everybody okay with that one so far? Okay. This right here, this is an alkylate group right there. Here we have the alkyl group coming off here. This one includes the alkyl group into that naming. Okay. Okay, so let's try it. So the first part you're going to do is you're going to take this group right here, and you're going to name that as the root, as the suffix. Okay? Then you're going to act like this group over here is a prefix, a substituent. Okay? You may have actually noticed this, by the way. We've used a few of these compounds in lab, the esters. So you may have actually noticed this naming scheme already. All right, so first we'll establish the O8 part of the name. That's going to be your alkylate portion. That's going to be the root for your ester. Okay, that's going to establish the number of carbons in that chain. That's going to be your root, your suffix. Okay. Then the number will number the alkyl and alkylinate chains. The C1 of the alkylinate chain is going to be this one with the oxygens on it right there. The C1 of the alkyl group is going to again be assigned to the carbon that's attached to that ester. Everybody okay with that so far? Okay. Okay, basically starting at the functional group, right? All right, so then we're going to establish the alkyl portion of the ester right there. That's going to get numbered off. We're going to write the parent name for the ester in the format where we put the alkyl part as if it's like a prefix. It's not quite a prefix, but very similar methodology, right? And then we're going to put the alkone name. There is a space between these two names. This is that difference because we have one that's attached to the oxygen, right? It's not on that chain. Okay. We're going to add the names and locator numbers for the substituents. Okay, so let's try this out on this one here. Okay, so right here we have the ethonate. How many carbons is that? 2. You got it. And so that would be ethane normally. We drop the E, we add the suffix. So ethanoate. Okay? Everybody want to try that with me? Ethanoate. Okay? I know, it is a little bit, yeah. Okay. So notice, by the way, that is not my longest chain, is it? Okay. Longest chain doesn't matter in this because the oxygen is on one side. That carbonyl right there. Okay. Okay, so I have my ethanoate. I've established that. I'm then going to go to the other side of the ester and count off those number of carbons. That's 3 carbons in this case. That would be a propyl group, right? Okay. I'm going to put that in front of it. Note that it has a space in between. Can everybody see that space? Okay. This is unlike the normal prefixes where we would not have a space, right? Okay. So there is a difference between these. Okay. Anybody have any questions? Okay. Okay. By the way, this is the common name for that, propyl acetate. And we name it as if this is an, do you guys know vinegar? Did you guys work with acetic acid and vinegar in your Gen Chem? Okay. Acetic acid, when it loses the hydrogen, goes to acetate anion, right? Yeah. And so this is the common naming, was to name them as if they're the ones that lost the hydrogens, like the salts would be. And you name them as acetate in this case, and then you have a propyl substituent on. Okay? That was the common naming. I'm teaching the IUPAC name, though. IUPAC name. All right. So right here, these are some more examples of these esters. Over here, we have this one right here. That's going to end up taking priority. And so that's going to be 1, 2, 3, 4 butanate, right? Okay. On this butanate, we have an oxo group. Everybody see that okay? And so we have to put a substituent on that. And so it's 3-oxo-butanate. That now gives us that acetate portion, right? That carboxylic acid portion of the ester. The next part we're going to do is we're going to then name this part right here. Okay? And in this case, we have 3 carbons in this chain. That's our longest chain on that side. Notice the space in between. Okay? Don't forget to put the space in between. Otherwise, it would look like you're putting substituents on the other chain, right? And then what we're going to do is we have a methyl on that. It's on the first carbon from that oxygen. Everybody okay with that so far? Okay. Okay. Anybody have any questions about that? Okay. Fantastic. All right. So this one right here, again, we have the pentanoate, 5 carbons on this chain. We have dihydroxy, 2 OH groups. They are on the 3rd and 4th position. this part right here then is the phenol. That's the substituent form for a benzene, right? pH, phenol. Okay. Everybody knows why the SS here?
Could you explain that?
It's the stereochemistry.
So, it's
So whenever you are doing the stereochemistry, what we would do is we'd have to go through and do priorities, right? And so hydrogen has to be coming out away from us. This is the first priority, right? And then we go through these, carbon versus carbon. No winner yet. Okay, then we go to the next one. So the next one's going to be the oxygen versus the carbon attached to here. The oxygen would be the winner. Yeah. And so that's S priority because it goes this way, right? Okay. And whenever we designate the stereochemistry of that, we always put those in parentheses in front of the groups we're talking about. And then we number them off, right? So the stereochemistry around this one is the 3S right there. This right here is the 4S. Okay. Okay. And anybody have any questions about that one? No? Fantastic. Okay, let's go an IUPAC name then. Everybody ready? What's the IUPAC name for this molecule? And then I've given you the configuration for the asymmetric carbon. It's S. So I'm not making you figure that out because we're mostly just concentrating on our new naming toys. Oh, by the way, if anybody freaked out because of it, I had to get rid of the old review extra credit things in Canvas. I'm going to put them back in. Yeah. They were updating as 0.
yeah.
Yeah. Yeah. Which was not helpful, was it? Yeah. I don't know why SmartWork does some of the stuff it does on Canvas. But so they'll be manually put in from now on. Okay, folks, I'm going to go and go on. If you haven't answered yet, please do. Okay, we have 89% that believed it was that, and that is correct. Perfect. Good job. Okay. I don't know why it does that either. I don't have any of these marked to show a leaderboard. There's something weird about the coding. Okay, so when we looked at this before, we're going to first have to figure out what's the highest priority group in this, right? So we have a nitrile, we have an alcohol on this, and then we have an ester. Everybody see those okay? So which one would be the highest priority between those groups? Yeah, the ester. You got it. You got it. And so we're going to name the ester. That's going to be the first carbon. That's also going to be our suffix. And that's going to set which one we end up naming as our root, right? Now, because it's an ester, that actually sets our root right off the bat. We can't do anything about that now, okay? And that's because this oxygen right here always tells us what number 1 is in our root, doesn't it? Okay? And so we go, well, it's 1, 2, 3 there, right? And so that would be a what? Is it 3? Yeah, why is it 3? Yeah, those damn nitriles are weird, aren't they? So when a nitrile ends up being a prefix, is not in our root, is not our suffix, we can't count the carbon in the nitrile. Okay? Another way of saying that is if you're going to have to use cyano, we can't count the carbon in the cyano. The CyO part, the CY part of the cyano, literally is the carbon. Yeah. So we end up with propane. That propane goes to propanate because we have an ester, right? Okay, and that is our root and our suffix. We then put our substituents on that and build that out with our substituents. In this case, we have a hydroxy, right? We have a cyano. Which one comes first? Cyano, perfect. That cyano is going to be on what carbon? The third, yeah. And then the hydroxy is on what carbon? The third as well, yeah. Yeah, because, again, that carbon here doesn't get counted as part of that chain. Okay, I told you the geometry for this. So in this case, we just have to put S. Do we have to number that S? No, there's only one place geometry could exist here. But if you did number the S, that would not technically be wrong. Okay? If you looked this compound up, I am absolutely certain there'd be 3 or 4 names that'd be listed as IUPAC names, and one of them would have 3S. Okay? However, if it only has one choice, you never have to put the number, right? That's the most correct. Okay? Okay, and then we go to the other side. Now we have to name that. We don't have any prefixes or anything fancy there, so we can just name it the ring, right? Okay. And so that is cyclopentyl. Everybody good with that? Fantastic. Okay, let's look at the acid anhydrides. What does anhydride mean, by the way?
Without hydrogen.
Yeah, specifically without water. Yeah. So we're going to go ahead and get rid of water in this reaction. This is actually the reaction of 2 carboxylic acids reacting together, and this would give the acid anhydride, which is why it's called an acid. It's the acids, and without the water. Yeah. I know, right? Some of these things actually make some sense. All right, so for the symmetric acid anhydride, you'll name the molecule according to the general form alkanoic anhydride. Okay? If the acid anhydride is unsymmetric, so these have different groups here, then we're going to go to this naming here, which is going to be the name the molecule according to the general form alkanoic anhydride. Okay? Partially because it being the same thing on both sides allows you to not have to list those as 2 pieces, right? You can just list it as one, and everybody knows then it's symmetric. Okay. So the 2 instances of the alkanoic will be different in this case, each corresponding to 2 different carboxylic acids that would be required to form the anhydride via that dehydration reaction. By the way, that's the type of reaction that is. Dehydration, i.e. removing water. You may have heard of dehydration reactions before, maybe in biology, maybe in terms of like making polymers. Okay? So the 2 instances of alkanoic should appear in alphabetic order, just as if you were doing prefixes. Okay? You can kind of look at these as if you're doing prefixes for the anhydride. Right? That's a nice way that mostly points you in the right direction. Okay? To remember this. So each of these carbon-containing compounds here is going to be propanoic acid. See that? If they were the acids, they'd be the propanoic acid. 3 carbon. Okay. And so this is going to be propanoic anhydride. Everybody good with that so far? Okay. This one right here, this would be benzoic here. This one right here would be ethanoic acid. And so we're going to put those together alphabetically. Benzoic comes first, B, then ethanoic, and then we say anhydride. Notice that essentially you're replacing the acid parts with the anhydride in these cases. Okay? Because they're no longer acids, you've lost the hydrogen, right? Okay. That is actually it. By the way, these are my QR things in case you're wondering what they're coming up with. What in the world is that, right? If you ever had a question that you wanted to ask and didn't want it to be public, that's how you do it.
I'm sorry, on that last example, you just said the times all comes first because of alphabetical
Mhm.
order. Okay.
Yep, yep. It's always alphabetic order. Wow, that's interesting. Okay. There we go. Yeah. Whatever your alphabetic order is, that's always how it goes. Remember, though, it's the alphabetic order for the specific group. Okay? So if we had substituents on those, that wouldn't change things. Okay? That's one of those parts that people sometimes get confused with. Okay? Okay. Did that answer the question fully? Okay. Fantastic. Okay. Did anybody have any questions about this material at all? No? Okay. Okay. Yep, and don't forget to practice, practice, practice. Because you're learning a language, and it is the language of science. Without the language of science, you won't understand much of the science that gets communicated to you, right?